This video, we are going to be talking about the quotient rule. So quotient rule is going to happen when you have some sort of kind of a function over another function, right? You got variables on the top and the bottom. And so you need to apply the quotient rule when you're doing the derivative. So the quotient rule is going to have kind of a feel of a product rule, but there's definitely more to it, a little bit more complicated. So to apply the quotient rule, we're going to be taking the derivative of the top times the bottom, or the top times the bottom, minus the top times the derivative of the bottom. There's almost the product rule. The only difference is we're adding versus subtracting. Then divided by the denominator squared. All right, so let's do that. So if we're going to do the product rule on this, we are going to take the derivative of the top. So 2x plus 3. Derivative of the constant goes away. So the derivative of the top times the bottom minus the top x squared minus plus 3x plus 4 times the derivative of the bottom. So the derivative of x squared is 2x. And then that whole thing is going to be divided by the denominator squared. All right, so it's the numerator that's kind of the complicated, the algebra part. Like the calc is done. Now we have to do the algebra. The algebra is going to probably be more challenging than the calc. So from here, we're going to do some distribution. We're going to do some distribution. There's going to be some like terms. We're going to try to factor and see if there isn't anything that we can cancel out. So we're cleaning up basically at this stage. So to distribute this, we're going to take the 2x distributed to both of those two. So we're going to have a 2x to the third minus 2x. And then we'll distribute the 3. So plus 3x squared minus 3. And then we're going to be distributing a 2 with a negative in there. Right, so that's going to be a 2x to the third with the negative. So negative 2x to the third. Right, and then we're going to have a 6x squared with a negative. 6x squared. And then 8x with a negative. And all of that is divided by x squared minus 1 squared. Remember, this is going to potentially factor into an x plus 1, x minus 1. We're just going to see if we happen to have an x plus 1 and x minus 1 out of all of this when we put it together. So don't know. So let's put some stuff together. So we have x to the thirds. We have a 2x to the third and a negative 2x to the third. All right, that goes away. And then we have some x squares. So we're going to have a negative 3x squared when we put those two together. Negative 3x squared. And then we're going to put our x's together, which is a minus 10x. And then I have a constant of a negative 3 over the same x squared minus 1 squared. All right, so let's see what we can do. This thing is potentially factorable. First thing I do want to do on this is let's take the negative out of it. So it'll be a negative 3x squared minus 10x plus 10x plus 3 over our x squared minus 1 squared. All right, and then the last of this is I'm going to try to factor this. So if I'm going to factor this, I need a 3x to happen when I multiply the fronts together. So a 3x and a 3 are going to multiply, or the 3x and the x are going to make 3x squared. I need this one and this one to multiply to 3. But if I notice there's no common factor that I can divide out, so I can't put the 3 there. My only choice is to put the 3 there, which makes a 1 here to multiply to make 3. And then if you multiply those two together and those two together, those are our like terms with our distribution, and they're going to add up to 10x. So perfect. So there's our factors. And then down here, we'd have an x squared minus 1 squared. remembering that this factors into an x plus 1 and an x minus 1, but it doesn't match anything. So then there's no reason to bother doing that. So that is the slope equation, the derivative of this original ration. All right, so sometimes the algebra is worse than the calc. All right, so let's do this one. So this one doesn't seem to look like much of a quotient. Like, where's the fraction on it? Well, it's because that negative exponent, d over dx, could be written as 1 over e to the x, right? Negative exponent's going to bring it down. So if we write it like that, now we definitely have a quotient rule. So if we were to do the derivative of the top, so the derivative of a constant is 0 times the bottom minus the top times the derivative of the bottom, so derivative of e to the x is itself, divided by e to the x squared. All right, so e to the x squared, we'll come back to, let's put together what we can. This goes away, and we're left with a negative e to the x over this. So I'm going to write this, rather than kind of bringing this in and multiplying it to the exponents, I'm going to break this up just to make it a little more obvious of what I can do next, is that e to the x squared is e to the x times e to the x, which makes it a little more obvious that I can simplify one of those out. And so my final answer is going to be a negative 1 on the top, e to the x on the bottom. Or if I kind of go back to this idea that I can pull that back up to the numerator and I just change the power on. So it's a negative e to the negative x. So either way, neither are wrong. And that's it. So that's us going through a couple problems involving the quotient rule.